Hello and welcome to this video. My name is Marco Nuyen and I'm a trainer at Microsoft. This video is part of a series of videos about the role of a Microsoft Cybersecurity Architect. In this video, we focus on aspects of applications and security. Discover how to identify and secure your applications with expert advice and practical strategies in this episode of the Microsoft Cybersecurity Architect video series. The content of this video is mostly aligned with the area of solutions for application data from a certification perspective. Now question, how to secure apps? This is the main question for this video, but you can ask yourselves other questions. Do you know all your apps? Do you know what they are? And do you know how they are being used? That's the kind of question you will need to ask yourselves and others to get an understanding. For this video, we will focus on three main elements: applications, discovery of them, and how we can control what we have discovered. Applications are a separate pillar in the Zero Trust framework, and we need to ensure that they receive adequate attention in our designs and executions. We need to understand apps, manage them, and collect data from them to improve overall awareness, to get visibility, automation, and orchestration. Apps are usually where the action is. And people will use a device over a network to access an app that will give them access to data. For example, how you use your email app or a communication platform like Microsoft Teams. How can we reach an application? Where is the application located? We may not always be able to see or manage that. I said in the video on identity that identity is the new boundary, it's the new security. The idea here is that by linking an application access with identities, we have a way to control it. The app needs to have evidence that the user is who they claim to be. If there's no evidence, we can ask the application to send the user somewhere to get verified. We let the user go back home, for example, to an Entra ID tenant. There we can clearly check and decide on access. We can see and record what happens towards an application. We can see and coordinate from a zero trust perspective, from a zero trust point of view. The graphic shown is in the MCRA, the Microsoft Cybersecurity Reference Architecture, and shows applications on the right side, users and devices on the left side, and a decision engine in the middle. The main point I want to make here is that we need to integrate with identity for control, visibility, and decisions. Identity is the control plane. And any application touched by a user in an Entra tenant will typically be something we will be able to see. More on that in a moment. The Microsoft Identity Platform is a cloud identity service that helps developers create apps that can sign in users and access data across different services and platforms. The platform supports various application types such as web, mobile, desktop, single page, and daemon apps, and gives different options for authentication and authorization, such as passwords, biometrics, certificates, or device-based security. The platform also has a range of development tools and software development kits, SDKs, to help developers work with different languages and different platforms. One of the main features of the Microsoft Identity Platform is that it uses modern protocols, such as Open Authentication, OAuth, and OpenID Connect on top of OAuth, to enable safe and compatible communication between apps and services. These protocols let apps ask for tokens from the platform, which can be used to access protected resources, such as user profiles, calendars, emails, or files. The platform also supports other protocols, such as SAML, Security Assertion Markup Language, and WS Federation for federated identity scenarios, where users can sign in using their existing account from other identity providers. Another feature of the Microsoft Identity Platform is that it lets apps phone home to Entra. By phoning home to Entra, apps can use its capabilities to improve security, privacy, and performance. For example, apps can use Entra to apply conditional access, multi-factor authentication, passwordless sign-in, or identity protection for their users. What it brings in is a link to identity. We get visibility and control over the access of an identity. But an application needs to be designed for integration. It needs to be able to use modern protocols. Otherwise, we cannot use all of the features and functions mentioned here from a zero trust perspective. And we will find applications that are not based on modern protocols. And yes, we should try to modernize them, but it will take time and cost and maybe not always bring a business benefit directly. Remember, we exist, we function to support the business. We help them to get and to stay secure. Modern protocols, such as Open Authentication and OpenID Connect, are designed for the modern world, where apps and services need to communicate across different domains and platforms. They enable federated identity, where users can sign in using their existing account from other identity providers, and they support token-based authorization, where apps can access protected resources by presenting tokens issued by the Microsoft Identity Platform. These protocols also allow apps to phone home to Entra and use its capabilities to enhance security, privacy, and performance. Legacy protocols, such as Kerberos and NTLM, are designed for a different era, where apps and services were mostly confined within a company's own physical network. They rely on domain-based authentication, where users have to provide their credentials to each app and service they want to access, and they do not support token-based authorization, where apps can access protected resources by presenting tokens issued by the Microsoft Identity Platform. These protocols, these legacy protocols, also do not allow apps to phone home to Entra and use its capabilities to enhance security, privacy, and performance. Therefore, modern protocols are preferred over legacy protocols, as they align better with zero trust principles and offer more capabilities to protect, detect, and respond to threats. However, some apps may still use legacy protocols, and we should try to modernize them as much as possible. Or we can think of putting something in front of a legacy app that pulls it into the modern world. In the graphic, we see an example of that with Entra Identity Application Proxy. It will allow us to leverage an Entra identity and explicitly verify and verification capabilities from there to get access to an application that natively, by itself, cannot support any of that. It is a proxy or a gateway pattern, and in the best practice documentations and the best practice framework documentation of the Cloud Adoption Framework and the Well Architected Framework, you'll see patterns like this being mentioned. There's another thing, enterprise applications. Any application that uses modern protocols and is used by a user in an Entra tenant will go back to Entra to get a token. Entra will have to verify the user, and it will have to give a token for the application to the verified user. But since Entra can only give tokens for things it recognizes, the application has to exist in the tenant. The process to create that presence is application registration. And that can be done beforehand, someone registering an application, but by default it can also happen automatically. The first user that goes back to Entra to get a token for an unknown application will start the registration process, and we will see the application in Entra ID. That gives us a control plane. The application is there, but we can control its behavior. We could say, no, that application is not allowed to be used. And if we do that, our users will not be able to use that application with their Entra ID account. It is a good place to check as a cybersecurity architect to know what applications are connected. We see an example of that on the screen. And then we need to plan if we want it, and maybe to want to control it a bit more. We want to maybe learn more about the application. What's its background? What's its purpose? Did we create and build it ourselves? And if we did, where are the designs and threat models for the application? Using principles from the Well Architected Framework for designing and securing workloads, or we could use elements from the MCSB around securing DevOps and DevOps processes, or we can see what the application is doing in real time. Have a visualization or a map of all the communication to and from it. Now, applications typically are not isolated, they are connected. Our application may have a front end, middle tier, back end, each with their specific security challenges. Each can use different kinds of capabilities, but we need to know. Otherwise, we cannot protect, detect, and respond. The graphic on the slide is an example of a map I took from Application Insights. If that's implemented, it's great to help us in our understanding. I've often used graphics like this generated by Application Insights, the Application Insights engine, and then do a comparison with the design model or the threat model, if that exists, and then use them all together to find gaps, potentially. One application or one capability that we need to mention when it comes to understanding apps and knowing what they're doing is Defender for Cloud Apps. It is part of the defenders that are under the control of Defender XDR, now the Unified Security Operations Platform, but it's a very powerful capability to discover, understand, and control applications after configuring and feeding it. Right? It needs to be set up. For example, by using connectors to applications, it can help us to understand applications by pulling in application-specific information, or by ingesting logs from proxies and firewalls, we can start seeing which apps are being used through those. It is all discovery and helps us to see the full picture. And it can also help us to understand the data that flows through and from the application and how that data is treated within the application. And it can become a control element. Because it's not limited to discovery and understanding, we can start enforcing. We can use it to start expressing rules like data labeled as internal should not be able to go to that application. Or we can configure that the data is only allowed to go to the application if it is encrypted. For example, by using mobile application management in an isolated bubble on a mobile device. More discovery, more enhancement, and more control for applications. Here we have an example of a dashboard that you may want to check out yourselves if your organization has turned on and configured Defender for Cloud Apps functionality. If not, then maybe consider start using it. And then there, before I omit it, for all the discovered applications, it will show the details of users, data, and dynamics of them. But also, it will help to understand compliance aspects and other information that Defender for Cloud Apps is integrated with by a team at Microsoft that evaluates applications. For example, if an application has a certain compliance statement available, it will be listed in Defender for Cloud Apps. And it can be very useful for your compliance journey, but that's a different topic in a different video. For now, we are at the end for this video. The topic was applications, and we looked at applications and discovery through Entra ID or Defender for Cloud Apps. And Entra and Defender offer us a lot of other capabilities to get a better understanding of our applications. Now, go read, go study, and the most important link for reading further about this is probably going to be the platform information, aka.ms/ID platform. So make use of that. You will find a lot of excellent content about application protocols, also how they interact. So it's really great resource to go and investigate. Well, thank you for watching this video. There are more in the Cybersecurity Architect video series. Meet you maybe in another one, and until that time, stay safe.